A new concept for wind turbines. Wind turbine meets erector set. This was a popular toy for children back in the 50s and 60s and 70s. First, the current status and the need. I begin with a demonstration of the current state of the art for wind turbines. The examples may seem like a complete waste of your time until at the end you realize that you've probably seen this in real life, and this is exactly and precisely the current state of the art and practice. Please bear with this extended illustration so you can get the full impact of the invention. We begin with installing a flagpole 20 feet high. This will require several bags of concrete mix in the base. Next, we will make the pole 50 feet high. This will require much more concrete, along with possibly some steel rebar. Next, we attach a 5-gallon plastic bucket filled with water, weighing approximately 45 pounds total, to the top of the pole. This requires a much larger pole and more concrete and rebar. Next, we make the pole 260 feet high. Yes, trust me, you have seen something similar, only much, much larger. The Lake Murray Dam in Irmo, South Carolina, USA is 150 feet top to bottom, and the Statue of Liberty is 305 feet high. Next, we will replace the 45-pound bucket of water at the top with a 2020 Ford F-150 pickup truck, which weighs about 5,000 pounds. How much concrete and steel are needed to support this, especially considering wind loads? I know this is ridiculous, but trust me, you have seen something much, much larger. Next, we will put a flat support plate on top of the pole or column, and on this plate we will park 23 Ford F-150 pickup trucks. That's 115,000 pounds, 57 tons total weight of the trucks. Trust me, you have seen something like this. That is 57 tons of dead weight atop a 260-foot column blowing in the wind. This is stupid, and yet you say I've seen this already? An average wind turbine today has a tower height of 260 feet, and its nacelle, which houses the electrical generator, weighs 115,000 pounds. An average sized wind turbine today has 29 tons of steel in its base. That wind turbine has 250 cubic yards of concrete in its base. That is 25 large cement mixer trucks, 10 cubic yards each. Near Roanoke, Virginia, in the USA, there are plans to install 22 wind turbines along the top of the Blue Ridge Mountains. Originally designed at 550 feet diameter, the developer now wants 680 feet. The Berge XL10 wind turbine is one of the most popular for home use. According to the Berge website, for this model XL10, the power head weighs about 1,000 pounds. Berge sells towers ranging from 60 to 160 feet tall. Let's assume a low average height of 100 feet. So we have a power head weighing 1,000 pounds atop a 100-foot tower. Let's put this in a different perspective. A 9-foot Steinway Model D concert grand piano weighs 990 pounds. So the Berge wind turbine powerhead is equivalent to placing a Steinway grand piano atop a 100-foot tower. How much concrete and steel are required for the base of the tower, given that they must withstand wind loads of 60 to 90 miles an hour? Here are some pictures of typical wind turbine blades. What's in the nacelle? The electric generator is often the largest, heaviest, most complex, most expensive, and most difficult to maintain component. The electric generator converts rotary motion of the shaft into electricity. We change gears here a little. There are 6 classical simple machines. How many can you name? We can apply one of these 6 classical simple machines to existing wind turbines in a way not done before to lower the design, construction, manufacturing, installation, operation, repair, and maintenance expenses. Let's put a pulley up here, another pulley down here, connect them with a cable, and let the generator rest on the ground, not 260 feet in the air. Please recall that the generator is often the heaviest component of the nacelle, which can weigh 115,000 pounds or more. That is the equivalent of 23 Ford F-150 pickup trucks or 115 grand pianos.